frequently asked if it is possible to increase the capacity of Combics and Midrics scale bases. The answer is a resounding yes, but, followed by a number of cautions and some disclaimers about scale performance. Often scale bases have significantly more load cell capacity than the published specification. Extending the capacity may be a harmless method of providing more functionality to our customers, but there are limitations. Today we will discuss factors to consider when extending the published specifications, both on capacity and on readability. We'll have a look at the actual load cell capacities in individual scales as compared to their published capacities and how much room we actually have to increase the capacity of the scales. We're going to talk a bit about recommended maximum number of division sizes by scales, and this varies between bench and floor and the type of scale installed in each. And finally, we're going to do some assessing of the customer's actual requirement. Oftentimes, customers will ask us to increase the capacity of a scale and even the readability without any consideration for the impact of the environment in which the scale is being operated. We often see situations where even at published specifications, the environment is not adequate to increase the performance of the scale no matter what we do from our end, and this needs to be made clear. No two installations are alike. Successful weighing range extension in a previous environment does not guarantee success in all environments. In other words, every single installation and application is different, and the considerations need to be made with all the factors in mind before we volunteer to extend the weighing range, either capacity or readability. The table on the left shows the actual capacity of the load cells installed versus the published capacity of the scale. You'll see in many cases that the scale capacity is actually about half of the actual load cell capacity, and this is to allow for a number of factors from dead load anticipation to loading anomalies and even the type of load cell that's installed in a particular type of scale. But in all cases, we've set up the table to be organized with the 4 types of cells that we're using because they all have different capacities relative to the published capacity. The most common is the single scale or single cell benchtop type scales, and in these cases the capacity is usually double whatever the published capacity is. And you can see some of the aluminum cells on the left hand side. We have a 15 kg published capacity with an actual capacity of 30 kg. So there's room to move on a lot of the benchtop type scales. The 4 cell scales have between 25% and 300% of published capacity. This would seem to give a lot of room for additional capacity, but there are considerations. The decks themselves are much heavier, and they tend to take a great deal more abuse in less conducive environments. Now, generally speaking, the maximum scale readabilities are limited to 30,000 divisions for 4 cell scales, 35,000 divisions for 1 cell, 40,000 divisions for 4 cell aluminum, and 60,000 divisions for some of the higher end single cell aluminum bench scales. These are the parameters in which we would prefer to maintain if at all possible. Let's look at some of the considerations for increasing the capacity and the readability of some of the existing scales. The most important factor in holding accuracy and performance overall is temperature variance. If we have a warehouse type environment with little or no temperature control, it may not be possible to increase either the capacity or the readability of the scale. The stability of the temperature is the most key factor in maintaining calibration and 0-point shift. We also need to consider the stability of the mounting surface, whether that is the floor on which the scale sits, is there forklift traffic, is there other vibration from heavy equipment in the immediate area, or even vibration from product that may be sitting directly on the scale. If we have a heavy machine that is vibrating and moving and processing material, it may prevent us from increasing the capacity because that would only exacerbate the instability. Operator technique is always critical, depending on the selection of the operator to use a particular scale, how the sample is loaded, and just general good, safe, and as gentle as possible loading technique makes a huge difference in whether or not it's possible to increase capacity and or readability. Loading procedures are crucial, but primarily on floor scales. We often see situations where when we increase the capacity of the scale, the off-center loading is increased. That is, you see more errors with higher capacity because more is exposed. There's also a phenomenon called rolling weight density. Rolling weight density is a situation that occurs when you roll a product onto the scale and the heaviest end is rolled on first. It could potentially overload the two cells that it crosses over first before it has the full support of 4 cells and is resting at its final spot on the platform. It's always best to roll in the lightest side of any component first to avoid any potential problem. But if that's not possible, it may be impossible to increase the capacity of the scale. Horizontal deck movement often occurs with a forklift load. When the forklift moves the product onto the platform and pulls away from the skid, there is a dragging of the platform in a horizontal direction. This is not something that works well with industrial floor scales. As the horizontal deck moves, the chances are good that you'll have a 0-point shift, and it may be impossible to load an even heavier sample with higher capacity under these kinds of conditions. And then, of course, shock load potential is always there. If customers are loading the product fairly carelessly and creating a shock load, increasing the capacity will only increase the potential for shock load, and it may not be possible to make changes to the published spec. So what's the best bet? Let's just kind of take a look at where you could go and the best possibilities for success when you're asked to increase the weighing range of a floor or bench scale. There's no doubt that benchtop single load cell scales are the easiest to deal with. As we saw earlier, they typically have 100% additional capacity, and they have fairly light platforms using up dead load and precious load cell capacity. So these become the choice for the easiest solution if somebody needs an increase from, say, 50 to 60 kilo. Usually can happen without a problem. Aluminum load cells are definitely better than stainless. Even a bench scale that has a single stainless cell has some hysteresis issues compared to aluminum cells, and consequently increasing the capacity may increase the hysteresis error. Anytime that the scale can be installed in a temperature-controlled area, it is a huge factor in increasing the potential to increase the performance of the scale. If we are in an unstable, variable temperature environment, it may not be possible to increase either readability or capacity. And then finally, if we're weighing liquid samples as opposed to powder or solid samples, that simply is much, much easier. The liquid tends to spread itself over the entire platform and consequently does not create the corner load problems that can be increased when we change the weighing range. Well, that's it for today. I hope we've given you some pointers of when it works well to increase the weighing range, both capacity and readability, and when it would not be advisable to give the best performance. If you have questions, please give us a call. We'll be happy to help you with any application that comes your way.